So here is our base code. So firstly we are importing some necessary libraries which will be used in our notebook, like Matplotlib for data visualization, NumPy for working on arrays, CV2 for computer vision, OS for working on operating system, and Globe for retrieving all the same pattern libraries. Then we are reading our dataset from our directory by the Globe, which will retrieve all the same pattern libraries. Like we can see here, we have retrieved all the JPG images with the help of Globe here in this code. Then we are counting how many images we have. So in our dataset, we have 6400 total images. Then we are plotting for sample image from non-dimented directory with the use of CV2. With the use of cv2.imread function, we are reading a single image and then converting from BGR to RGB, because CV2 by default reading image into BGR. And then with the help of Matplotlib, we are plotting our non-dimented image. Then we with the same very mild dimented and moderate dimented. After all this, we are creating a loop for applying label on the images. So here we are reading our data set with the help of loop. We are reading all the images in the loop, and then we are reading a image into 208176 by the help of cv2.resize method, and then we are appending it into data. And also we are giving the label of all the images according to directory. Like if the image we are giving getting from the mild dimented, then we will label it as 0, and if we are getting the image moderate dimented from the, then we are labeling it as 1, and 2 for very mild dimented, and 3 for non-dimented. After applying all the label, we are plotting sample images after this. So we can see now we have sample images non-dimented, mild dimented, VMD. Then we are converting our images into array and labels into array. After this, we are splitting our data set with the help of train test split method, and we are giving here data and labels to split our data into train and validation data. So after this, we are using two categories for converting our images into categorical form. So now we can see we have for after applying two categorical, and also we are applying data augmentation here, in which we are using width shift range, height shift range, shear range, zoom range, horizontal flip, and fill mode we are using nearest. After this, we are creating our model with the help of TensorFlow. We are implementing our model DenseNet 201, in which we have weights ImageNet, and we are using shape 1763208 according to base paper, and also using global average pooling 2D, and dropout layer with the final dense layer, in which we have activation softmax. After this, we are plotting model summary here. We can see it here, and then we are training our model with firstly we are compiling our model, in which we have optimizer Adam with the learning rate 2e minus 5. Also we have lost the categorical gross entropy, and then we are training our model with the help of training data and validation data, in which we have batch size 32, and we are training our model on the 10 epochs. So now on the last epoch, 10 epoch, we can see we have validation accuracy 87, and training accuracy we have 89. After this, we are plotting accuracy and training accuracy and validation loss graph. So we can see this blue line represent the training accuracy, and orange line represent the validation accuracy. And also here we can see training blue line representing training loss, and orange line presenting validation loss. Then we are making prediction and extracting feature with the help of DenseNet 201. So after extracting feature from the help of DenseNet 201, we are using these feature to classification the images of Alzheimer diseases with the help of support vector classifier. So here we are importing the per support vector classifier from sklearn and training our model, in which we are passing the extracted feature from the DenseNet 201, and also making prediction with the support vector classifier. So our support vector classifier are giving us the accuracy 0.87, and here we have classification report, in which we can see precision recall F1 score according to all the four classes. Here we can see we have precision recall F1 score according all the four classes, and then we are printing final training accuracy of our model, precision recall, and M1 score. Also we are plotting confusion matrix here, so we can see this is the confusion matrix, and here we are evaluating specificity and sensitivity. And then we are using second model, which is Gaussian Naive. Again we are passing extracted features from the DenseNet 201 to train our Gaussian Naive model, and then we are making prediction which gives us accuracy 0.86. And this is the classification report for Gaussian Naive. And final model we are using XGBoost, which is giving us the accuracy 0.88. So this is our base code. Now we are jumping on our proposed code. So again in our proposed code, firstly we are importing some necessary libraries like matplotlib, numpy, random, cv2, os, globe, and retrieving all the same pattern library from our files from our directory with the help of globe. And then we are plotting some sample images here of non-dimented, very mild dimented, and moderate dimented. For plotting these, we are using cv2.imread to read a single image from our directory and then converting it into BGR to RGB and plotting it with the help of matplotlib. Then we are here in this loop, we are reading our dataset with the for loop, in which we are reading our images by the help of cv2.imread and converting our image from BGR to gray. For the image enhancement, in which we are using Clahe. Then we after image enhancement using Clahe, here we are converting our image into BGR to RGB. And then we are resizing our images from 96 to 96 and labeling it as if we are getting image from mild dimented, we are labeling it as 0, and if we have moderate dimented, we are using 1, and if we have very mild dimented, we are using 2, otherwise non-dimented. And plotting some sample images here. And then we have unbalanced data. So for the problem solution of this problem, we are using smooth to balance our data, in which we are passing our data and labels. Here we are firstly reshaping our data into single 1D data, and then we are using smooth, in which we are passing data and labels. And now we can see after using smooth, we have our balanced data, in which we have all the four classes already have been balanced. After this, we are splitting our data into training and validation data, in which we are using testing size 20% and training size 80%. Then we are using two categorical and also applying data augmentation for overfitting, in which we are using width shift range, height shift range, CR range, zoom range, and then creating our model by concatenating two transfer learning model VGG16 and DenseNet 201. We are creating a new model by concatenating two models VGG16 DenseNet 201, in which firstly we have input layer, in which we have saved 9696,3. Then we have our VGG16 model with the weights ImageNet, and then we are creating our model, in which we have input and output D1. Then we have second model DenseNet 201, in which we have again weights ImageNet, and pooling we are using Max. After all, getting all the outputs and extracted feature by the VGG16 and DenseNet 201, we are concatenating the output of both of these two models by the concatenate method, and then we are giving final dense layer for the classification, in which we have activation review. Then we are again building our model with the model one dot input and output. We have our concatenated model feature and printing the summary, in which we can see we have VG16 DenseNet 201 when final dense layer, and we have optimizer add-on with the learning rate 2e minus 5, and loss we have categorical cross entropy. And then we are training our model with the data augmentation, in which we have batch size 32 and we are training our model on the epoch 50. This is the architecture of our new concatenated model, in which we have VG60 and DenseNet 201. We are firstly passing the input layer to both the model and then concatenating the extracted feature by these two models, and passing our final fully connected layer, and then evaluating training and validation accuracy, which is 0.99 0.93 respectively. And this is the training accuracy and validation accuracy graph. So we can see in the blue line representing training accuracy and orange line representing validation accuracy. After this, we are printing the classification report, in which we have precision recall F1 score for all the 4 classes 0, 1, 2, 3, and average accuracy we have 0.94. And this is the confusion matrix of our concatenated new model, and this is sensitivity and specificity. And here we have ROC score of our model, which is 0.95. And finally we have a precision recall curve, we can see it here, of our new concatenated model. Also we are using this model for feature extraction. We are using also this model for feature extraction, and we are extracting feature by this model. Here we can see to create our new hybrid model, in which we have 5 classifier: catboot classifier, multinomial Nebase, SVC, XGBoost, and AdaBoost classifier. We are concatenating all these models into voting classifier, passing this model into voting classifier, and using soft voting for getting the average accuracy. After applying all these five models, we have final accuracy 0.94, and this is the confusion matrix of our voting classifier. And here we have multi-class ROC curve, and we have precision recall curve of our hybrid model. This is our precision recall curve for voting classifier, and this is the sensitivity and specificity of hybrid model, which is 0.9940 and 0.9984. So this is our proposed code.